Albireo was started in 2014. Actually, Jim, if you don't mind going forward one slide. I forgot introductions. We took care of that. So I'm going to talk for a minute about Albireo, and Dave's going to talk about the stuff that's really interesting. So we can go to the next slide. Albireo was started in 2014, and the idea behind Albireo was to build a national independent integrator. And so we've been doing acquisitions across the U.S. And the acquisition that we've done here was a company called GXP Automation, which was started in 2004 by a couple of ex-Schneider guys, actually, who had a vision that there was an opportunity in the marketplace and a need in the marketplace for someone who really understood pharmaceutical life sciences. And in fact, when you really sort of dig under the covers and look at what they did, what they recognized was that there was an opportunity for validated manufacturing and research spaces. And that's really where we focused over the last 15 years of our existence. And the vast majority of our customer base was there. And in order to fill that void, if you could hit the button one more time, Jim, what we realized was you need somebody that understands how to bring together building automation, process automation, validation requirements. And frankly, when they went out and looked for products, we settled on Delta because of the foundation of Backnet, because it gave us a platform off of which we could start to bring together all of those things from a technical standpoint and marry up with the expertise that we built within the organization. So that's what we do, and that's where we've been focused for the last 15 years. And Dave's going to talk to you about a couple of projects that we've been involved in where it really brought together that whole story. Dave?
All right. Next slide, please. So what we're going to talk about today is we're going to outline one case where we've done something that we think has been really unique to the market. So next slide, please. Here we go. I just want to just do the whole slide at once, and then I'll talk about it. Right there, perfect. Okay. So we've actually done this a few different times, and I'm going to talk about one case here. I'm not going to mention any names of what we thought was a really unique integration method where we were able to utilize BACnet, and we'll talk about the nice features that we liked about that. So there was this opportunity we were faced with a few years ago where there are these two new facilities being constructed in a big, large pharmaceutical campus. The existing infrastructure on campus was 100% Rockwell automation architecture. So they had 3 or 4 buildings in place already. Someone had sold them back the day that SCADA system was the best way to go, and they have this Rockwell huge SCADA architecture everywhere, and that's what they wanted to move forward with. So they had factory talk, SCADA system, all of their BAS control was through their controller, Compact Logix controllers. They had a PI data historian, they used Win911 for alarming, so they had a full-blown SCADA. And they're adding these 2 new facilities, one of which is a clinical manufacturing facility, and the second of which is an R&D facility. And the caveat to this project was they needed to maintain the existing architecture above. No exceptions. So we couldn't come in and offer our Delta products, which we rep, a nice Delta installation, full Backnet installation. We needed to maintain those conditions, which they had in bullet point 2. So next slide. So before we go further, how many people here, I guess, have worked in manufacturing scenarios or understand what this diagram is? Most people, okay. So typical manufacturing suite, hit enter a couple more times and fill the data out. So you have multiple VAV boxes serving into a room. Whether it be 2 supply, 1 exhaust, 2 supply, 2 exhaust, you've got multiple different scenarios in an actual suite. There are also multiple ancillary points required. So you have room DP, you have your control parameters of return temp, return humidity. You may have a door switch to lock the control loop open if someone opens a door in an active pressure scenario. You may be monitoring equipment in the room. Next bullet point there. So you're maintaining your critical parameters is absolutely critical to the product quality. So the product's dependent in these rooms on temperature, pressure, humidity, amount of air changes. And the big challenge is how do you design around this? So enter again. So not only how do you design around an HVAC control standpoint, but how do you design around this scenario to support a multi-protocol integration? So that's kind of what I'm going to talk about is how we designed a system to fit those parameters of the existing SCADA that was in place at the site. So next slide. Okay, so our solution. So what we decided to do in this case was option one was we're also a Rockwell rep and Rockwell integrator, would be to put a whole Rockwell system in. So we put control logics in and air handlers, you can put compact logics in, one processor to do 50 VAV boxes, and it's just this messy setup. It costs a lot of money, and I don't think there's a lot of value add in doing that type of topology. So what we decided to do was, why not utilize BACnet controllers for all control and monitoring functions? We have these beautiful controllers that not only Delta makes, but all the other manufacturers. You have VAV controllers with built-in damper actuators and flow sensors and application fan coil controllers, all of which cost a couple $100. And we deal with these every day, and we take them for granted, to be honest with you. So a couple more bullet points here. So we also needed to provide integration of all these BAS controllers into their SCADA platform. There's a plethora of ways you can do it, but the ways that we decided to do it here was we would use what's called ProSoft BACnet IP cards. So these are basically cards that would go into a ControlLogix chassis and connect up BACnet IP to your BACnet network, and there's basically a CSV file in these cards, and you map the points over you need to map over. So we would put, we had a handful of ControlLogix in each building. We put our ProSoft cards in. We did our configuration, mapped all our BACnet points, and brought them right into Rockwell through the ControlLogix. We built the existing screens on the FactoryTalk platform, so there's no need to retrain their staff in new BAS hardware or any new software. Next bullet point. And we were able to utilize the existing alarm engine, and one more. We were able to utilize their existing PI historian. So nothing changed from a SCADA standpoint. And they were able to use PI historian for all the data acquisition, their alarming engine. So we didn't create any alarms in the BACnet side. We integrated to the Rockwell side, and then we made the alarms there. So next slide. So I probably made that sound really easy. It was actually quite a challenge to do this. Well, you just fill this slide out. So in doing this, and network speed and reliability are obviously paramount. So it's paramount when you're designing a regular BAS network. Where how many devices you put in an MSTP loop. How long my IP runs, and that's enough of a challenge on a regular BAS. But when you talk about integrating all of those protocols, into another platform, and then layering that on top, you need to think about it even more. Polling intervals. How often are we going to poll the network from those ProSoft BACnet card standpoint? We have to make sure that we're not overloading the ProSoft cards we have, and we're not overloading the network at the same time. So we needed to figure out how we're going to do this and how we're going to put all this together. So we developed this really nice demo kit that we brought into the customer, where we had a ControlLogix and all these ProSoft cards, and we had actually our Delta software, and we built the graphics and had this whole network set up. And we went through and we commanded points back and forth, read write between the Delta side and the Rockwell side. We showed the data integration, all of it, and they were pretty impressed. So it was quite a challenge to do it, but we got through it. So next slide. Just fill it out, yeah. So some of the things that we had to keep in consideration is utilizing BACnet IP controllers where possible. So I showed you that manufacturing suite example before. What we found out is that trying to do conventional VAV control with all of those points created a huge bottleneck for us. Even if we had a powerful system level controller with a powerful processor, we still were getting a bottleneck up at the HMI side when we pulled up a floor plan, for instance. So we pull up a floor plan of 10, 15 boxes, and we would get a huge delay in terms of getting all that data from the VAV boxes through the system controller, up into the ProSoft cards, through the ControlLogix, all the way into the SCADA system. So what we decided to do was utilize IP controllers where possible. So from a speed standpoint, this was paramount in making sure that we didn't have those lags. So we would use basically one system level controller to do control of 2 to 3 suites. So all those points we show would go up to this one system controller from an IP standpoint. And in doing that, it also reduced the amount of points of failure that we would have in the rooms. So for instance, instead of having,
Was it a challenge? Was there a lot of MSTP?
There was. So each building was different. In the manufacturing building, there were the same type of layout. You've got air handlers, you have VAV boxes. So we would lump them together based on manufacturing suites. So your typical layout is you'd have one air handler that would serve 3 or 4 suites and support areas. So we basically have an IP level controller for the air handler and an IP level controller taking care of 3 or 4 suites. And that was kind of the sweet spot we found. Another suggestion or another solution we had was segregating third-party BACnet devices. So we would try to take third-party devices, VFDs, chillers, boilers, those types of things, and segregate them on a different segment of our network than we had our Delta devices on. Not that they're not good devices or they're not perfectly fine BACnet, but sometimes you'll have a manufacturer that'll have 200 variables or 200 points on a chiller, and we found that mixing those with our MST networks would sometimes slow it down or communicate at a different baud rate, and in order to maintain that integrity all the way up to the SCADA side, we segregated those on their own MSTP loop. So a couple more slides. And then we minimized our MSTP network size. This was the biggest one, and it took some trial and error to figure out how big we could go in terms of a network size. And one more. So we basically kept it below 50 devices where we could. So we basically have a system level controller, a repeater with 3 legs, and we put 15 or so controllers on each one. So next slide. You just fill the slide out again. So the benefits of using the BACnet product is it is a significant lower cost in comparison to PLCs. I don't know if people have seen the cost difference, but we saved a considerable amount of money in terms of using PLCs to accomplish the HVAC control. A big benefit is using the purpose-built controllers. So like we said before, I think we take it for granted that we have all these wonderful controllers that can do all these purpose-built things from an HVAC standpoint. The hardware is designed specifically for it. And in the PLC SCADA world, they don't have that. A big thing you don't think about is universal inputs and outputs. You know, you figure you get a thermistor, or you have an RTD, or you have a 4 to 20, you just wire it to input 1, right? It's pretty simple. But in the SCADA worlds, you need a specific thermistor card. You need a 4 to 20 input card. You need a amperage input card. So it's the cost just totally snowballs in the PLC world. Ability to use a distributed network approach versus a centralized process topology. So going back to the VAV controllers and fan coil controllers, from a PLC standpoint, you're stuck with one control Logix, one compact Logix, and that's the brains of the operations. Software objects and templates built around HVAC. You know, we've all got control objects and special objects built into our controllers that are designed for HVAC. And then the ability to integrate multiple platforms. So, you know, if you've got a PLC that doesn't natively speak Backnet or Modbus, so you need to put translators in anyways to speak to your chillers, to speak to your boilers, speak to your VFDs, those types of things. Next slide. So, last one. I don't mean to gloat, but we've done this 6 times since 2015 on $1 million projects on multiple large pharma sites. So we've gotten better at it each time, and we really take pride in this. So, next slide. That's it. Questions? Yes.
I'm surprised to hear 50. You were supporting as many as 50 MSTP devices?
Yeah.
MSTP?
Yeah. I mean, that's more in the office and support areas. So on the manufacturing side, with all those points, pressure, humidity, door contacts, we used IP level controllers. But on the office side, when you just have room temp and discharge temp, we stuck with the box controllers and the small MSTP network. Yep.
One of the challenges of doing this type of integration is that the model that each protocol uses for how control should be done is not always the same. So back many years ago when we did our first connecting project, we were working with Carrier
Yeah.
and their legacy product, and for example, a priority system that didn't quite match BACnet's priority system. Certainly, that's only one small example. Alarming is often done differently in different protocols.
Of course.
Could you talk a little bit about some of the places where you had challenges in trying to map the model of how BACnet sees the world into the Rockwell control object world?
Yeah. In terms of getting the BACnet points to Rockwell, we had some issues originally with actually mapping the points over. We would have to map. Milton, you help me out here, man. Yeah, this is this is a little above me here, man.
So we did have issues with the priority arrays.
Yeah.
So the product line that we were using didn't really have a priority array. So when we were talking about on the Albireo and Rockwell side, when they write to a point, it just writes to a point. They didn't care about what priority it was at, or who was commanding it for. So we took the stance that if anyone's commanding anything from the HMI, it would be considered a manual override, it would be considered an operator override. So we took that, and everything that was written from the HMI would come in at that priority level, come in at, I forget the exact number, I think it's 5 or 8, or higher. Yeah, so we would write anything from the Rockwell side would write to that priority on that, and immediately override what our programs were sending, or even what on the Delta side was overriding. So that was one of the challenges we overcame, was just having that understanding ahead of time that if anyone deliberately touches the front end correctly, then they're taking responsibility that they're overriding the program within our controllers. So that's one of the examples of how we overcame that. Another example would be the polling rates. So, even in Modbus or Ethernet IP, things are operated much faster level than BACnet. In terms of everything there is a directed message. So if a controller is asking for something, it'll ask it for as fast as it wants. It doesn't follow any rules about how quickly the client can respond. So the way we overcame that was we just set all of our scan rates to about 5 seconds, and that was acceptable for what they were doing from the front end. And it's mostly acceptable in the HVAC world to have data come in at around that 5 second, even though that's not normal in the process world. When you make changes in the process world or you command objects, you expect an immediate response. But in the BACnet world, things operate at a different level just because of the sheer number of points and the discovery and the broadcasting aspects of it. So it's a lot about education for the customer, about understanding that the pros and cons of this process. It's not a seamless transition, and the technical hurdles are mostly about education and having the customer have an understanding that this is what it takes to do this.
Another deep technical question. How did you keep alignment between the PI database and the metadata, the data standards, and the naming that was used there on the Rockwell industrial side and the naming that was used for the BACnet devices? And did you use Haystack or anything else?
No, so the way the naming works is, we're used to our naming, the plain English naming of a word, like discharge temperature or room temperature. So I think what you're alluding to is in the process world, everything is tagged with an ISA standard.
Right.
So for example, like TT, it would be a temperature transmitter, PT, a pressure transmitter. So what we did was we actually used a combination of both worlds. And on all of our controllers, we kept the naming, the plain English naming. So it's mostly for our service techs too, because they don't understand the ISA naming. So, but what we did was in the description field of all of those points, we put in the ISA tag.
Right.
And then in the Pi world, we basically just created a giant spreadsheet of our names and our BACnet IDs, and then also the the ISA tags for everything. So in all of our documentation, we show both. We actually show plain English name and the ISA tags for everything.
If you did a just plain vanilla BACnet job, would you use tagging standards? The BACnet tagging standards, haystack?
We have our own naming
You have your own?
standards, yeah.
Okay, great.
But we are getting towards that, is to have more conventional naming standard that aligns with the industry.
Right.
But yeah, because we work in the pharmaceutical industry too, we come across a lot of ISA tagging, and the way we've worked around that is by putting both. And in our front end, we display both on our graphics and our navigator windows, so that our technicians can understand what they're looking at and our customers can understand what they're looking at.
Great.
Follow up, I'm really interested to know, with an HMI override, I assume you ask them twice. What's the text the second time for "Are you sure"?
So on that front end, it actually, because it's 21 Part 11 compliant and it has a lot of the auditing built into it, a lot of that is you have to put in a signature every single time you want to make an override. So you have to retype in your username and password to make that change. And they can even enforce comments. So you have to describe why you're making this change. So a lot of that's already built into the SCADA systems, including factory talk.
Did you run into any problem with relinquishing control of the point?
Yeah. So that's definitely an issue.
I'm sorry, what?
Relinquishing control of the point after a force.
So from the Rockwell front end, what you can do is if an operator commands something in override, it also shows an override in the Rockwell side. So when they release that override, it'll also send the relinquish command down to our controllers. So that's how we relinquish the Backnet side of it.